Everyone, in today's video we are going to look into the Spark memory management. So on the screen you can see there is a Spark executor memory. So the executor memory or the JVM, whenever a executor is created, a JVM, Java virtual machine, is created. You write a program in PySpark, you write a program in Scala or Java, anything, there will be internal JVM container will be created. In PySpark also it happens because it is created on the as a wrapper on the top of the Scala based programming language or JVM. So internally in the Spark execution, there will be a JVM container created for each executor. So this is an executor memory diagram which you are seeing here. Left side, this portion on heap memory. On heap memory is a part of JVM. Okay, and this is the part of the memory parameter which we provide to the executor. If we say that Spark executor to be 20 GB, that means that 20 GB is going to get assigned to on heap memory. Off heap memory and overhead memory is something very different. We'll talk about these two parameter in the later part of this video. But first we'll focus on heap memory. So on heap memory have four different memory section. The first is execution memory, the second is storage memory, and third is user memory, and we have a something called reserve memory. So what do we mean by the execution memory? So when you do any joins, shuffle, sorting, or any group by, so that takes place in the execution memory. So in execution memory, you can say that joins, shuffle, or any of the transformation, sort by, group by, all this takes place into the execution memory. In the storage memory, generally when we are caching any RDD or data frame, anything. So if you're writing an RDD program or a data frame program and you are doing caching of it, so in that case, storage memory is used. When you are using broadcast variable, at that case also storage memory is used. So execution memory and storage memory combined is known as, or it is called unified memory. So this is very important. You will get to read in multiple documents. So this is, you can write it here like this. So this is your unified memory. So this is not going to combine here. Okay. So execution memory plus storage memory is known as the unified memory. You can write it here, unified memory. Now there is something called user memory. So user memory is used to store the variable, the object which you have created while writing the program, or also when you have written a UDF, user defined function, when you create at that time, this user memory is created, not in the storage memory. It is used in the so user memory is used to store your UDF when you create an external UDF, when you create a variable, when you create an object, at that time user memory is used. So reserve memory is something which is reserved for some purpose, and this is there by default, and by default there will be around 300 MB of size of the reserve memory. So this is about on heap memory. So this lies under the JVM. So when you give the parameter like there will be 20 GB of executor memory. So on heap memory is the 20 GB, and there will be different division of that 20 GB depending on the watch parameter you have set, and also depending on the default value. Now we'll look into how this memory number, or the number which we give to the executor memory, how it gets divided into different section. Okay. So I'll start with one of the memory parameter. I'll write it here. So the parameter which I'm going to write is executor memory. Okay. So for example, I have set executor memory as 20 GB. Fine. So what happens internally for this JVM container, 20 GB is being assigned. Now in this 20 GB, there will be different division. So there is something called Spark memory fraction. Spark dot memory dot fraction. So in the Spark memory fraction, by default its value is 0.6, And you can also set this fraction. So what do we mean by spark memory fraction? Spark memory fraction is the combination of memory number of execution memory plus storage memory. So with this parameter, we will come to know about the combination of unified memory. So your unified memory will be 0.6, 0.6 into 20 GB, and this will comes around 12 GB. So your execution memory plus your storage memory is 12 GB. So you have assigned 20 GB to the executor memory, but for the in this 20 GB, for the execution and the storage memory, it comes out to be 12 GB. Now we have around 8 GB left. So when we deep down into the unified memory, so there is one more parameter for the storage memory. So the parameter name is spark dot memory dot storage fraction. So this memory defines the memory of the storage memory. So you can give your number, you can customize this number as per your need, but by default this value is 50%. This is 0.5. Okay. So in this case, the example which we have taken, in this one, your storage memory will become 50% of the unified memory. So we have unified memory of 12 GB. So 0.5 into 12, and this comes out around 6 GB. Now with this calculation, the storage memory is 6 GB, and then your execution memory becomes 12 minus 6. Becomes 12 minus 6, and this is equal to 6 GB. Right? Now we'll go into the user and reserve memory. So we have around 8 GB left. So we have assigned 20 GB to the executor memory, and in this 20 GB, the unified memory becomes 12 GB. So you have left with 8 GB. So that means your user plus reserve memory, this is now 20 minus 12, this is 8 GB. Okay. Now reserve memory is generally 300 MB. Okay. So your user memory becomes, you have this 8 GB minus 300 MB. So you can change this MB to GB, and then we'll come to know the exact number of the user memory. Okay. So this is how your memory, whenever you define the executor memory, and this is how it get divided into different memory section. You can tweak, or you can change the memory parameter inside this, but if you leave it by on a default, so on default this calculation will go on. Now there is two more thing, like overhead memory and off heap memory. So off heap memory is, we'll talk more into it in the later part of this video. Just give you an overview. So off heap memory by default it is disabled. So default value is disabled. So when you enable this off heap memory, then you have to give the size of the off heap memory. Overhead memory has a calculation of it has a calculation of max of, by default, 384 MB or 10% of execution memory. Okay, so then you can calculate 10% of your our executor. This is not execution, this is executor memory. So 10% of the executor memory means we have assigned 12 GB. So 10% of 12 GB is 2 GB, either 2 GB or 384 MB, which is bigger. So in our case, the 2 GB is bigger. So 2 GB will be assigned to overhead memory. If you look more detail into off-heap memory, so off-heap memory is also divided into two sections: the execution memory and storage memory. How we have execution and storage memory as a section in on-heap memory, the same kind of two different section is also available in off-heap memory also. We are not going into detail of that. Whenever you submit an Spark application and you give the instruction like you need a container of 20 GB. For example, you are given as instruction that you want an executor memory of 20 GB. This will go to the yarn, and the total memory which will be assigned to your container will be 20 GB of the executor plus overhead memory. So when you tell your yarn that you need 20 GB, so in practical you will be assigned more than 20 GB. So 20 GB for the execution memory for the JVM, and the rest memory, more memory will be assigned as per the formula, or as per the calculation of the overhead memory. So for example, in our case, overhead memory is coming around 2 GB. So the total memory which will be assigned from the yarn will be 20 plus 2, it will be 22 GB. So in our case, this comes out to be 2 GB. So the total memory which will be assigned from the executor will be 2 GB and plus 20 GB. That becomes 22 GB. So unified memory generally works in a dynamic memory allocation mode. I mean to say, like, the execution memory and storage memory generally divide the memory within themselves as per the requirement. For example, you have assigned storage memory as 6 GB, and if you don't have a cache of the RDD or data frame in your program, so in that case your most of the memory inside the storage memory will be empty, and that can be utilized by the execution memory. The other way around also it can happen, like you have the full space in the storage memory and you need more of execution memory, then some of the parameter or some of the cache things will be moved to the disk, depending on the algorithm of least used algorithm, and that space will be empty and that can be used by the execution memory. Sometimes you need to add more into the cache, and there will be multiple the transformation things or metadata which is there in the execution memory, that can also be evicted, that can also be removed as per the requirement. This is all divided by the Spark. We don't have to manually remove any parameter. We just have to mention executor memory and few of the parameter if you require it, or leave it as by default. The Spark internally by itself will distribute all the memory, will understand this dynamic memory allocation. One more thing I want to discuss, like as I have told, like in the unified memory, the execution memory and the storage memory divide the memory in the dynamically mode. That happens only after Spark 1.6. So before Spark 1.6, the storage memory and the execution memory do not dynamically divided the memory. There was a strict, or there was a fixed storage parameter given to the storage memory and the execution memory. But after Spark 1.6, this dynamic memory management is done by the unified memory. Few more things I want to mention here. Like for example, your on heap memory is full. So if there are multiple transformation, cache, everything is going on, and if you've created multiple UDF also, if your on heap memory is full, in that case your Spark application will get stuck. But actually it doesn't get stuck, because at that time GC is getting called. GC means garbage collection object, or garbage collection cycle will be called or will be initiated at this time. Garbage collection cycle will start, and this will start removing few of the memory of the on heap memory. Depending, this will be done by the internally by the Spark. We don't have to call the GC garbage collection, and then the some memory will be evicted, and then your Spark program will be resumed from there. Everything is done internally, we don't have to do anything. But in case your on heap memory is full, and when the GC garbage collection is called or triggered, your performance of the Spark will be degraded a bit. Now when on heap memory is full and GC garbage collection is triggered to remove the on heap memory, at that time off heap memory is also useful for managing the Spark application. Now you have to remember one thing: on heap memory is a part of the Spark, it's a part of the JVM. But off heap memory is a part of OS. So off heap memory is managed by operating system. So your GC, garbage collection, will not work on the off heap memory, it will only work for the on heap memory. So we have to manually manage the off heap memory with our program or outside from our OS. So whenever we are using off heap memory, whenever we have enabled off heap memory, at that time it's the duty or it's the responsibility of the developer to manage the off-heap memory. If after the application with the OS command, you have to remove the off-heap memory so that the space is not getting full, or it cannot be used with some other Spark application that may cause some degradation in the whole of your system, because OS is a part of your whole server, so that it will degrade the whole server. So whenever you're enabling the off-heap memory, so at that time you have to manage it manually. But this GC and on-heap memory, you don't have to manage manually. This will be taken by the Spark internally by itself. I hope you are able to understand how the Spark memory allocation takes place internally, and how we can use this memory parameter, use this knowledge to optimize our Spark application. If you have any doubt, please mail me and ping me. Thank you.